I welcome you to VINDAL'S concept. This is physics practical for Neco 2023 on electricity. Now, if you look at these are the apparatuses we are given. We are given resistance box, rheostat, ammeter, 2-volt or 3-volt cell, wires, torchlight bulb, and key. There are most important thing I want to point out here. This torchlight is nothing but the resistor. So, because every load or every light, every bulb you have in your house is a load, and they have a certain amount of resistance. So that is why I am putting it here as a resistor. However, we are using torchlight to represent that resistor. Now, one thing I want you to know is that there are different kinds of bulb. There is a kind of bulb you will use. 2 volts or 3 volts will not be able to power it because it has a very high resistance. So you must be very careful with the kind of bulb you are using. Like they stated, torchlight, it will be a very small bulb. I'm going to show you how to use the bulb and so that the current can pass through it and so that it can glow. And when we go to the practical. Now look at how I set the circuit. This is the battery, this is my rheostat, this is my resistance box. If you look at this diagram very well, you see that resistance box and this bulb, or simply called a resistor, is the same thing. So resistance box and that bulb, they are in series. Now I connected this voltmeter in parallel in order to read the potential difference between the value of the resistance box and the value of this torchlight bulb. Then this is my key. This is the ammeter where I'm going to take. This ammeter is recording the current flowing in the whole circuit. While this PD is recording the potential difference between the resistor of the bulb and that of the resistance box, which we are going to be doing. So there is nothing special about it. And if you don't take a very good resistor, your one, remember, the ammeter you're using is just 0 to 1. 1 ampere of a ammeter will not be able to read it. So you must be very careful. Maybe you can change one of them. When I was carrying out the experiment, I found out all this. Now, coming to this aspect, the method, I don't want to write so much. It's just very simple experiment. Set up as shown. So when you connect this, which I'm going to show you when we go to the lab, you say with 0 resistance box, that means do not open any key of a resistance box. You say using a rheostat to record a maximum current, I naught, I sub 0, and then V naught, V sub 0. Leave it there throughout the experiment. That means I am going to increase my rheostat. When I increase it, I have a highest current. Then I leave the value there throughout my experiment. Now I say set up R1. Then I will go to my resistance box, open one key, which is 1 ohm. When I open that one, I will record what V is giving me, and I also record what my I is giving, my ammeter is giving me. I'm going to do that for 2 ohms, 4 ohms, 6 ohms, and 8 ohms. And in each case, I am going to record IV, and I'm going to evaluate this. This is resistance. This you are seeing there is just total resistance. Because the total resistance here, which is this P, is V over I. Which is the total, the PD of the battery and the total current flowing through the battery. Now, this is what I'm going to do. And then at the end, I'm going to plot a graph of P versus R. Now, I'm going to show you what is the meaning of P and R, what we are going to plot. Let me do a little analysis on that. Now, this P, like I said, this P, you remember, according to Ohm's law, V is equal to I RT. What I mean by RT is effective resistance or total resistance. Now, how do we get RT? This RT is the resistance of the resistance box plus the resistance of the torchlight bulb. Therefore, we say that RT is equal to V over I. But in this case, they say we should call it what? P. Now, if I plot a graph of P against R, simply means that I'm plotting a graph of RT over R. That is the graph I'm going to plot. And that means my slope is not going to have any units. It's not going to have any SI unit. So that is what we have. Let's quickly go to the lab and carry out the experiment. Thank you. Okay, we are now in the physics practical like I promised you. So I'm sure you must have seen the theoretical aspect where we were explaining how the practical is going to look like. Now I have with me the first thing they say we should use is this is Rheostat, and this Rheostat has different designs, all of them, but the one I'm going to be using, this one should wait for now. So I'm going to be using this big one, because sometimes some of you in physics, in your physics lab, some of them may not be working, but you have to test the one that is working very well. So I've seen that this one is working very well. If you see, I connected my wire here in this part, then I connected at this top. But even if you connect here and here, I am sure it will still work, but you need to test it depending on your own design. So please don't take everything hook, line, and sinker. Now this is the slide. As you are moving this, you are increasing or reducing current. So this is my rheostat. And this is my resistance box. In my resistance box, you can see the numbers written there. This is a kind of design. But let me show you another resistance box. This one is another resistance box. So if you see the numbers written there, when I open it, that is when the resistance box has started working. But when you close it, you are not using it. But if you are closing it, you have to close it tight so that the resistance of the wire will not be introduced into the circuit without your knowledge. So this is my resistance box. And this design, different designs. The next thing, I have connecting wires. I don't want us to talk so much about it. What I want us to talk about is this one, the bulb and the light. I decided to use this kind of bulb. Let's see how it works. I connect this one positive part of the battery. Okay, now I positive to positive. So you see the bulb is on. But this kind of one is just LED bulb. But it's not really the one they say we should use. But I'm trying to improvise. Like I was saying, there is nothing different. There is nothing different between this bulb and this resistor. The only thing different is that this one has a different resistor from this one. But what am I saying? They are all load. They are doing the same thing. Just that this one does not have light to show. So resistor and the bulb, they are the same thing. I also have another one. See, another kind of bulb. Now let me show you this one now. If I connect this to this 3 volts, you see, it's on, but it's too tiny. The light is too small because the voltage cannot carry. The resistance of this bulb is too high. Now see how I connected it. One, use sodium ion, connect one. Let me open it so that it will not be running my battery down. I use one, connect to the body. This is the cathode, and this is the anode. This is the anode. It's already hot. Very hot. It's already hot. You know, all these hot cathode bulbs. But don't use this one. The resistance of this one is too high. We are going to use a very small one, tiny bulb. I have not gotten it, but we are going to improvise. So these are the bulb we are going to. Okay, let me increase my battery. Come, bring it. Let me show them. Let me show this one. Let us see how this battery will work. See the light. A little better, but the battery is not good enough. You see the light. So the resistance of this wire, of this bulb, is too high. Okay, you already know the key, the ammeter and the voltmeter. Okay, all right, let us set up our apparatuses according to the diagram we are working on. So remember, the question on the day of your exam may be different from this, but this is going to give you a full experience and a guide for your experiment. If there is time, I will show you cheats. But for now, let's do this. So I'm starting with this cell, which is the battery. From the battery, I will connect to one part of my rheostat. So from my rheostat, I will go to my one portion of my resistance box. So see, I entered here. I will go through this place, then come out here. So this is out. From the rheostat, from the resistance box, I'll go to my battery, my torch. This is my torch. But wait, I can still use this to show you. But I will explain to you, like I said earlier, I made it before, that this torchlight is simply a resistor. I can still remove this one and put a resistor. It doesn't make any difference. They're all the same thing. The only difference is that this is a standard resistor. I know the value of this resistor, but I don't know the value of the resistance of this torchlight. So we are using the torchlight according to what they say we should do. From the torchlight, I will go to the key. This is my key. From the key, I will go to my ammeter. Then from that ammeter to I will also connect my battery to the ammeter. So everything is connected except my voltmeter. So this voltmeter, how am I going to connect it? I want to connect my voltmeter parallel from the resistance box up to the torch. So what my voltmeter is going to be recording is the total resistance of the resistance box and that of the resistance of the torchlight. But there is a friend of mine too who is running a YouTube channel, Selaxi Educational World. His own connection is different. You can also check his channel. So, but this is how I'm setting up this one. Any of them can go. So this is how it is. Remember that my bulb cannot glow. Why? Because the resistance of this bulb is too big. This 3 volts cannot carry it. If I close the key now, you see my current is on. If I close the key now, check if. So if I close the key now, you see the current is recorded. The current is recorded. If I remove it, the current is off. But see what happens to the bulb. Let's go to the bulb. The bulb is not on. Even though my current is recorded, yet my bulb cannot because the resistance of my bulb is too high. If you also check my voltmeter also recorded. So let me open the key. However, let me remove this bulb and put the other bulb to see, so that you will see what happens. This so let's close. Watch what my current will do, and then I will show you what the bulb is going to do. What's the value of my what's the value of my voltmeter? Check. See the value of my voltmeter. The voltmeter is there. The voltmeter has taken so much, but yet my bulb has not shown anything. Pause. On it. Okay, let's close the key. See, another thing is this. These two. Stay a little fast so that you can capture these two and capture everything. Any issue, let me know so that you know.
No issue. I'm just changing
Okay, the
light.
intensity. Oh yeah, let's start. Can we start? Okay, let me close the key and see if my bulb will be on. I'm closing the key. So you see the voltmeter. Voltmeter has recorded this value. Current did not increase. Why would the current be too low? It simply means that the resistor is high. When the resistor is high, the value of the ammeter, or which is the current, let me bring them close so that you be sure. The value of the ammeter will be very small. See, it's making some move, but it's too small. And then when the resistance is high, the voltmeter will also record very high, but the current will be recording very low. But see what we'll do. Let me increase my current by touching the rheostat. See my rheostat. I'm going to increase. Let's watch what's going to happen. Okay, you are seeing what's happening. The voltmeter is increasing. See, it's reducing. It's reducing. I increase it. Why? According to Ohm's law, the higher the current, the higher the the potential difference. However, because the resistor is too high, this is not making any much difference. But I'm going to show something. Let's make a difference. Pause it. Have you played? Okay. When I close the key, you see my bulb is on. As the bulb is on, let me increase the light. You see, as I'm increasing the current, the brightness of the bulb will be going higher, as higher and higher and higher. So if I'm reducing this, the brightness of the bulb will be going low, 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 and down. So this is what rheostat does to increase the value of that. Okay, but then what do we notice? What we also notice is that as I'm increasing the current, the voltage will be increasing. You see, as I'm reducing, it's also going to be reducing. To be reducing, going down. However, but the voltage is reading very high. That means the value of the resistor, or the value or the resistance of this bulb is very high. That is why this is also going to be high, because what this is recording is the total resistance on the series between the resistance box and this. But on the other hand, the value of this current is very low. Why will it be low? Because it's not moving, it's not showing any sign. Even though this is high, is because the resistance of the wire is very high, the current is going to be very low, because resistance and current, they are inverse according to the principle of Ohm's law. Pause it. Are you done? Okay, so what I'm going to do now is I've closed my key. So I remove the torchlight because the resistance of my torchlight is very high. I'm going to use this 1 ohm resistor in place of the torchlight. I've said that over and over again. So what I'm going to do is according to the instruction, they said I should increase to have the highest current. So I'm going to close my key and watch my ammeter reading. What's the ammeter reading? As the ammeter reading, I'm increasing it. Okay, so let me keep my ammeter reading here. This is what I want to use as my highest value of my current. Now, let me open the key of the resistance box. When I open one, you will see a very small change in my ammeter value. Very small change. As my ammeter value is going down, the potential difference is increasing. Ammeter value is going down, potential difference is increasing when I open the key. All right, when I open 2, more of this will happen. So we are going to be taking our reading. So the first one, according to the instruction, is I should find the value of this I naught. This is I naught now. and this is my V naught. So let's take the reading. Bring this thing. Let's take the reading of the value of the voltage when the rheostat is reading highest maximum value for the current. So this is our maximum voltage and this is our maximum current. So let's take the reading. Where is my pen? Okay, so I'm taking my reading under tray. This is 0.1. V naught is 0.1 volts. Why I naught is going to be, don't worry, no, wait. See now.
Yeah, this one is clear, but when I was doing from here, the video doesn't.
Okay.
I need to be closer.
This is my V naught. So this is my I naught. 0.4. Call it. Or you pause it. I naught or you play this thing. Are you seeing me? Okay. So according to this, I'm going to have R, which is ohms. I'm going to have, I already have my I naught and V naught. So this is V naught. So I'm going to have, the next thing is going to be current in ampere, voltage in volts, then P, which is V over I. And this P, like I told you, P is something as, because V is equal to IR, therefore R is equal to V over I. But this R is the total resistance, which include the resistance, of the resistance box and the resistance of the torchlight. Okay, so this is how we're going to have our table and recording. So let's go to the next one. I'm going to open 2. All right. Okay. So let's go to resistance box and open 2. So this is 2. This is 2. I'm opening 2. Let me type 1 very well. So this is 2. 2 is open. So as the 2 is open now, let me close the key. I've closed the key. Okay, current has reduced a little and voltage has increased a little. So let's go. Let me check it. This is going to be, this is 0.2. Okay. That is the value of my current. This is current when resistance is 2 ohms. And this is the voltmeter when the resistance is 2 ohms. Hey, so the 2 ohms are open. This is 2 ohm. 2 plus 2 that are open, that is 4 ohms. I've introduced 4 ohms from the resistance box into the circuit. So let's close the key and see what happens to the current. Okay. This experiment is too good, like 0.08. Then this is what happens to the voltmeter. It's increasing. So I've taken my recording. This current is recording when I have 4 ohms from the resistance box. My current is recording 0.358 according to what I was able to find here. You know, you are using the video. You are from the other side. I know what I'm saying. So, but I'm very careful. So from this side, I'm having 0.3. So, and that is what I have recorded here. Okay. So you are noticing the trend. So I have opened 1, 1 is open, and 5 is open. So I have 6 introduced into the system. So let me show you what is happening to the voltage at this point when I close my key. When I close the key, see the voltage. Voltage is increasing very, very good. 0 point is in the 6.5 division. 6.5. This is 5, 6. 6.5 division. And this is how I have run the experiment. This is how I have run the experiment. I hope this will help you. I hope this will help you. Thank you very much.